Given an array, we have to return true if any value appears at least twice in the array, and false if every element is distinct. Now one way to do this would be to compare every element in the array with each other, and return true if we find any duplicates. For example, let's say this is the array of numbers. Then first, we'd compare 1 with every element in the array, starting with 2, then 3, and so on. Now that we know that there are no duplicate 1s in the array, we'll move on to 2. We already compared 1 and 2 here, and we don't need to compare 2 to itself, so we'll start with 3, then 4, then 5. We didn't see any duplicate 2s, so now, using the same logic, we'll look at row 3, then row 4. We don't need to do this last row, because all the comparisons with 5 have already been done here. At this point, we verified that there are no duplicates in the array, and we would return false. Now this approach works, but the problem is that this algorithm runs in O of n squared time. If you're not sure why that is, skip to the end of the video, and I'll explain why that is. But there is a way to do this in O of n time, and the way we're going to do it is, as we traverse the array, we're going to store the value into a hash set. Then, as we come across new values, we'll look up those values in the hash set to see if we've already seen it before. If we have, then we'll return true. And if we get through the whole array without seeing any duplicates, then we'll return false. Now the whole reason this runs in O of n time is the fact that hash set lookup runs in constant time. This is because, similar to a hash table, a hash set stores values by taking the value, calculating a unique hash, then storing it in the set. Then, when you need to check if a certain value is in the set, you don't need to iterate over all the elements in the set. Instead, it just calculates the corresponding hash and jumps straight to it to see if it exists or not. Okay, now let's look at the Python code to see how we can implement this. Let's say that this array at the top is the input array, nums. The first thing we'll do is create our hash set, and I'll call it numset. Then we'll iterate through the array using the variable I, so I starts off as 3. Then we'll check if I is in the set. Right now the set is empty, so we'll jump to the else block and add 3 to the set. Next up is 8. 8 is not in the set, so we'll add that too. Next we'll look at 4, which isn't in the set either, so we'll add it. And next is 6, which again needs to be added. Now I is 4 again, and when we check in the set, we see that it's already there. This means that we have found a duplicate, so we can just end now and return true. Now what would happen if the array didn't have any duplicates? Let's use this new array as an example. First we look at the first element, 2, and add it to the set. Then we'd look at 7, add that, 5, add that, and finally 3, and add that too. Now we've reached the end of the loop, and we haven't found a single duplicate, so we can just return false, and we're done. Now, going back to why the first solution was O of n squared, if the length of the array is n, then the first iteration took n minus 1 steps. The second iteration took n minus 2 steps, and so on until we reach 1 for the last iteration. So how many steps is that total? We can use this formula here that tells us that the sum from 1 to n is n times n plus 1 over 2, or n squared plus n over 2. So to find the sum to n minus 1, let's take n squared plus n over 2 and just subtract n from it. After a bit of manipulation, we can see that this ends up being n squared minus n over 2. And since with big O notation, we only take the dominant term and drop constants, this ends up being O of n squared.